So, in today's class, we want to consider structures of straight chain alkanes. It is important for you guys to understand how to draw the structure, how to give the structures of some hydrocarbons. It will really help you a lot in our next lecture on how to write all these structure. At times, you may need to represent this structurally. Maybe you draw the structure, you give the structure, or you want to write a chemical equation. Without knowing how to write their structure, it will be very difficult for you. And it will be also difficult for you to understand the practical aspects of chemistry. So let us see structures of straight chain alkane. The very first member of alkane is methane. It's methane with molecular formula CH4. So because carbon is tetravalent, we give it. Since an hydrocarbon, so we have 4 hydrogen there. We have one of it here. One. So sometimes we write the condensed structure of methane, or we give the structure of methane as this. The next member of alkane series is ethane. Like we have done in our previous class, which has the molecular formula C2H6. So this is 2 carbon. You write the 2 carbon first. To 1 carbon atom, there is always 4 bonds because carbon is tetravalent. Then we attach the hydrogen. So here we these 3 hydrogen and another carbon, 3 hydrogen. And this is the structure of straight chain for ethane. The third member is propane, which is C3H8. We have 3 carbon, C, and C. So carbon is tetravalent in all its compounds, virtually all. So we attach the hydrogen, attach the hydrogen, attach the hydrogen, attach the hydrogen. So to this first carbon, we have 3 hydrogen. To the second carbon, we have 2. To the third carbon, we have 3 hydrogen. Then the condensed form, we can see we have CH3, 2, and we have CH2 for only this, because this is just a carbon atom in between these 2 carbons. Then we can draw the condensed form of this as CH32 for ethane also. Then the next member, which is the 4th member, is butane. So having done the structures of straight chain alkanes, and let us see how we can give the IUPAC nomenclatures of some branch chain hydrocarbons. And we have some IUPAC rules that is guiding us on how to give the IUPAC name of branch chain alkanes or organic compounds generally. But we'll start with branch chain alkanes, so we are going to start with a very simple aspect of it. So let us consider this structure. So let us go to the condensed form. This is a carbon, 3 hydrogen, this is CH, then we have CH3, then we have another CH3. Now, the first thing we need to know here, the first IUPAC code that we need to know is for us to identify the longest continuous carbon chain. When we say longest continuous carbon chain, is by counting the number of carbon atoms continuously by not going forward, then you now come back to count. Just like you say 1, 2, 3, that's continuous. But in the situation where you say 1, 2, you now say 3, then you come back to this top one and say 4. No, that is not a continuous carbon chain. But a continuous carbon chain is when you can't direct, like you go continuously. Just you can say 1, 2, 3, or you say 1, 2, 3. So when you identify the longest continuous carbon chain, then you give the name of the alkane. For example, for this is 3 carbon atom. An alkane with 3 carbon atom is propane. If it is 4, an alkane with 4 carbon atom is butane. If it is 5, an alkane with 5 carbon atom is pentane. So the first thing to do is to identify the longest continuous carbon chain. Having done that, for this is propane, 3 carbon. Alkane with 3 carbon is propane. We write down the propane. Now you now look at it. One of them is not among the one we can. This is it. So we take that as a substituent. We call this a substituent because it is not part of our continuous carbon chain. So that becomes a substituent. And the something you must know. You know, our alkane, they have this general molecular formula CnH2n plus 2. But by the time you remove one hydrogen atom from alkane, it becomes alkyl. They form a substrate known as alkyl. And alkyl is formed by removing one hydrogen atom from alkanes. And this one becomes Cn. Let's take another example so as to understand this hyperclose very well. Let us consider this. Let's consider another compound. Now, what we need to do is to identify the longest continuous carbon chain. Let us see. This is 1, 2, 3, 4, 5. Let us check if we still have another one. 1, 2, 3, 4, 5. Let us check if you can see have another longer than that. 1, 2, 3, 4, 5. Oh, the longest continuous carbon chain is 5 carbon. And alkane with 5 carbon is pentane. So we take this 1, 2, 3, 4, 5. Or you say 1, 2, 3, 4, 5. So it's equal. So when you look at this is 5. This is the substituent. And the substituent here is CH2, which is the same thing as C2H5. And we have the substituent C2H5. It's referred to as ethyl. So we are going to write the ethyl in front of it. Ethyl. And we look at the position where it is attached to. It's attached to carbon 3. So we see 3 ethyl pentane. But what if we now have more than one substituent? If we have more than one substituent, there will be more than one number. So we use comma to separate those numbers. Then if we want to separate the number from the names of the substituent, we use this hyphen. So let me give an example on that. I have H3C, CH, CH3, CH, CH3, then CH3. So right now we identify the longest continuous, that is carbon 4, which is butane. Then we have an alkyl group, which is methyl. Both of them is methyl. That is methyl. But since both of them is methyl, we use di for 2. If there are 2 alkyl groups of the same group, we use di for 2. We use tri for 3. We use tetra for 4. We use penta for 5. We use hexa for 6. We use hepta for 7. We use octa for 8. But because there are 2 here, we say di. Then we now look at the position. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 1, carbon 2, carbon 3. This is equivalent. So here is 2, then we have another methyl on carbon 3, then hyphen dimethyl butane. This is 2,3 dimethyl butane. And there is something I must chip in this case. We can draw their condensed structure. We can draw their example. We need to identify the longest continuous carbon chain. And this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, 6, 7. Or you say 1, 2, 3, 4, 5, 6, 7. Now that is 7. Or maybe you want to count from this end 1, 2, 3, 4, 5, 6, 7. So the longest continuous carbon chain is 7, and that is heptane. Now, how are you going to name this compound? If I want to name this compound by IUPAC rule, we have to start from the right hand side. This is carbon 1, carbon 2, carbon 3. That is, and on carbon 3, ethyl is attached here. 3 ethyl. On carbon 4, we use IP to separate that. On zinc carbon 3, we have methyl, that is 3. On carbon 4, we have another methyl, that is on 4. Then on 5, we have 5, 5. But since there are 4 methyl now, that will be what? Tetramethyl. Then heptane. Now, but let us see. Let us start from this side. Maybe we'll be right. We don't know. Let us see. Here is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So it means we have 5 ethyl. Then we have what here? 3, 3. Another comma, because of these 2 is on 3, 3 in that case. Then we have 4. Then we now have 5 tetramethyl heptane. So let us calculate the locant number. Here will be 5 plus 3 plus another 3 plus 4 plus 5. So this is 20. If I'm not mistaken, that is 20. Then let us calculate the locant number here. Here is 3 plus 4 plus 10. Isn't it? That is 17, and that is also 20. So but this one is actually correct. Both of them are equal. So whichever one, but this I will go with this because it looks more sensible. I also go with this because the first substituent to be named here has lower locant number compared to the first one here. This one is 5, while this one is what? Is 3. So we say this one is right, while this one is what? Despite the fact that they have the same total locant number, but the first substituent here, which is 80, has lower number compared to this.